So next we come to the next topic on this method of first differential equation of first degree and first order is homogeneous equation. So what is this homogeneous equation? So the differential equation m dx plus n dy is equal to 0 is said to be homogeneous when m and n are homogeneous function of the same degree in x and y. So any differential equation of this form m dx plus n dy equal to 0 is said to be homogeneous if m and n are homogeneous function of the same degree x and y. As homogeneous equation can be expressed in the form dy dx is equal to phi of 1 upon x. We name it as equation, and it may be solved. How to solve this homogeneous equation? By using the method of substitution, that is, you replace y upon x by v, or y is equal to vx, where v is a new dependent variable which depends on this y and x. So using the substitution in 1, you replace y upon x by v here. We have, if you differentiate this with respect to x, what do you get is dy dx is equal to v into dx gives you 1 plus x into differentiation of v, that is x into dv dx is equal to phi of v. So therefore equation 1 now becomes v plus x dv dx equal to phi of v, and the variables now can be separated. You can solve it again by the method of separation of variables. So after performing the integration, means after you integrate this, what you do is you replace again this v by the original value in terms of y and x. So you replace again this after integrating this. So you replace it by y upon x to obtain the solution, or to get the solution of a homogeneous equation. So here this is one example. Solve x plus y into dy dx is equal to twice y. So you can write this as x dx plus y dy is equal to twice y dy. Bring this twice y to one side, cross multiply with dx, so you'll get x minus 2y will be into dx plus y dy is equal to 0, which is homogeneous and can be expressed in the form of phi of y upon x, that is dy dx is equal to twice y minus x by y. So since it is a homogeneous equation, and to solve it you have to substitute y by vx. Then differentiate this with respect to x. What we get, if you differentiate it, you get y dy dx is equal to v into dx, but dx gives you 1 plus. Now keeping x as constant, differentiate with v with respect to x, we have x into dv dx. So therefore, replace this in, therefore equation 1 now reduces, instead of dy dx, you write it as v plus vx into v plus x dv dx is equal to twice vx. What is equation 1? Equation 1 is this: x dx plus y dy is equal to twice y dx. Or you can write this as 1 plus, multiply this, you will get v square x plus vx square into dv dx plus twice vx. Or you can write this as 1 plus, and you can see from here x can be taken common, so it will be get cancelled. So what remains here is 1 plus v square plus vx into dv dx is equal to twice v, or 1 minus twice v plus v square is equal to minus vx into dv dx. But 1 minus twice v plus v square is nothing but v minus 1 the whole square, that is of the form a minus b the whole square, that is a square minus twice ab plus b square, which is equal to v minus vx into dv dx. So you can separate the variables now, the x and v variables separately. So we have here dx by x is equal to minus v divided by v minus 1 the whole square into dv. Now since you have separated the variables, what do we get here is you integrate them. So we have integral of this dx by x gives you log x, and integral of minus sign you can keep it outside. So you can write this as v minus 1 plus 1. You just add and subtract by 1 divided by v minus 1 the whole square. So if add and subtract by 1, it will remain as v only. So now you take one part of this divided by v minus 1 the whole square. So what remains here is dv by v minus 1 minus, because of this minus, so this will become minus. So 1 divided by v minus 1 the whole square. But integral of this one minus dv by v minus 1, this can be written as dv is same as dv of dv minus 1. So when you integrate it, you will get log of v minus 1 plus 1 by v minus 1 plus c equal to minus log of y by x minus 1. You replace it by an integral of this. Again, this can be written as you can see here, d of v minus 1 by v minus 1 is same as dv by v minus 1. Now using the properties of integration, integral of dx by x gives you log x. So instead of x you have v minus 1, and here also integral of 1 by x dx by x to the power n, you replace v minus 1 by x, so you'll get integral of dx by v x square is nothing but minus, but because minus already there, so you have plus, so 1 by v minus 1 plus c. So therefore this is the not the required solution, because required solution is in terms of x and y. So you replace v here by y upon x. So from here you have y is equal to v upon x, so v here will be equal to y by x. So therefore the required solution will be equal to log x is equal to log x by y minus x plus x by x minus c, y minus x plus c, where c is there an arbitrary constant. So it is not possible for me to discuss each and every problem. So let me do one more problem from here. So in case if it is not clear, but I have mentioned the steps clearly here. So if it is not clear, then you can ask me. So one more problem I can discuss with you is this one. dy dx plus y upon x is equal to y square by x square. Now this can be expressed in the form of dy dx equal to y square by x square minus y by x, which is in the form of phi of y by x, that is homogeneous equation. So once it is a homogeneous equation, what we need to do is replace y by v upon x, differentiate this with respect to x, you get dy dx is equal to v plus x dv dx. So therefore equation 1 now reduces to, you replace this dy dx by this value, and the left hand side also it will be v by x the whole square minus v upon x, since y by x is equal to v. Or from here bring this v to this side, it will become minus, so that's why you have v square minus twice v, and from the left hand side will remain as x dv dx. Or you can write here this, you can separate the variables separately, the x and v variables. So we have here dv by v square minus twice v is equal to dx to this side divided by x. Integrating, we get integral of dv by v into v minus 2 is equal to integral of dx by x. So here v square minus twice v, you can take v common outside the bracket, so you have v into v minus 2. Now using this, solve it by partial fractions, you have done this in class 12. So half of this one, integral of 1 by v minus 2 minus 1 by v will give you dv by v into v minus 2 is equal to integral of dx. Now this can be integrated as integral of dv separately. So integral of dv by v minus 2, this 2 here will get cancelled once you cross multiply this one. V into v, 1 gives you v minus 2 into 1 gives you minus v minus 2. So that v and minus v get cancelled, so minus into minus plus 2, so there is no 2 here, so that's why I have introduced here 1 upon 2, so that 2 which comes from here will get cancelled with this. So here you have half log of v, because integral of dv by v minus 2 is same as integral of d of v minus 2 divided by v minus 2, which is log of v minus 2, and integral of dv by v gives you log v is equal to log x plus log c. So here we have 1 by 2 into log of v minus 2 divided by v, because log a minus log b, from the properties of logarithm, log a minus log b is same as log a by b, and log a plus log b is equal to log a and b. So using these properties will apply here. So log x plus log c, I'm writing here the constant term also in terms of log, so I have log of cx. Now take this half you can write it to this, because there is a one properties on log, that is n log a is same as log a to the power n. So half log of v minus 2 by v is nothing but log of v minus 2 by v to the power half, but 2 to the power half is nothing but square root of v minus 2 by v is equal to x, where this log vanish because we are taking exponential on both sides. So e to the power log of something gives you that value only. So therefore we have v minus 2 by v to the power half, or you can write it as square root of v minus 2 by v equal to cx. So from here what we have is squaring both sides so that the square root will be removed. What remains here is v minus 2 by v is equal to c square x square. Now in the question we are to solve a differential equation in terms of y and x. So you replace this v by y upon x. So we have y upon x minus 2 divided by y upon x is equal to c square x square, or this y minus 2x divided by y upon x, x cancel. So you have y minus 2x is equal to c square into x square into y, cross multiply it to the right hand side. So this will be the required solution. I hope it is clear to you. So the rest of the problem you see, if anything is not clear, then you let me know.